Hello students, now I'm going to solve the next numerical from chapter number 9, light reflection and refraction, class 10 science, and I'm solving the numericals from your NCERT book. So let's start with the question. So the question says a concave lens of focal length 15 centimeter. So focal length is given 15 centimeter, forms an image 10 centimeter from the lens. So this is the image distance. Image distance nothing but small v. So small v is given, that is 10 centimeter. How far is the object be placed? So we have to find out object distance, that is small u. We have to find out object distance from the lens and draw the ray diagram. So question is very clear. F is given, V is given, U we have to find out. But remember, as I will be always telling you, have to write the signs properly. So start the question. So I'll write here answer. And now, as I told, first we have to write what all given values we have. So I'll write here given. See here we have focal length. So here our lens is concave. So it will look like this. This is the principal axis. This side is called left side. This side is called right side. Left side all the value will be negative. Right side all the values will be positive. So in case of concave lens, what about the focal length? So if this is the ray which is going parallel, it will goes to the lens, it will get reflected and goes diverged. So it get diverged like this. Another ray, if it is going parallel, it goes like this and get diverged like this. So where they are going to meet, they will not meet on the other side of the lens. So they will, if I extend the reflected ray on the same side of the lens, so they will appear to meet here on the same side from where the rays are coming. So I hope you are understanding. After reflection, the rays of light will appears to meet on the same side. So this is called as focal length. If this is principal focus, then this is called as focal length, that is small f. And this is also on the same side. Therefore, focal length in case of concave lens will be negative. So I will write focal length. So focal length, what is the symbol for this? Small f. And here how much focal length is given? 15 centimeter. So I should write 15 negative. See here, negative 15 centimeter. Then we have image distance. So see here in the diagram, wherever the reflected rays will meet, there the image will be formed. So here all the reflected rays are going to meet on the same side. So our image will be formed on the left side itself. Therefore, image distance will be also negative. So I'll write here image distance. And what is the symbol for image distance? Small v. How much it is? 10. So I should write minus 10 centimeter. And what I have to find out? I have to find out object distance. And object will be always placed on the left side only. So this answer, after finding, we should get negative only. So this is question mark. Now we have to use our lens formula. So I'll write according to lens formula. So what is our lens formula? As we all know, the formula is 1 by f is equals to 1 by v minus 1 by u. In this formula, what we have to find out? We have to find out u. So rearrange the formula and we can write it like this. So if I take this minus 1 by u on the left hand side, it will become positive. So plus 1 by u is equals to 1 by v is as it is. And this 1 by f is positive. It goes on the right hand side, it becomes negative. So this is the rearrangement of formula which we have done. Now we can substitute our values in this formula. So what all the values? We have everything. So substitute it. So I'll write 1 by u is equals to v is how much? Minus 10. So I'll write minus 10. Here negative sign. F is how much? Minus 15. So see here, signs are very important. You should not go while writing the signs. So 1 by u is equals to, first I will solve signs. So this minus 10 is as it is. This minus and minus will become plus. So I'll write plus. Here it is 15. Now what we have to do? We have to find the LCM of these both. So therefore let me solve the LCM. So I'll write here 10. Here I'll write 15. I'll take the prime number 5. 5 2s are 10. 5 3s are 15. Then 2 1s are 2. 3 as it is. Then 3 1s are 3 and this 1 is as it is. So LCM is equals to 5 into 2 into 3. So what I'll get here? 5 2s are 10, 10 3s are 30. So therefore LCM is equals to 30. So we got our LCM. Now we will substitute into our numerical. So see here what I'm going to write. 1 by u is equals to, what is the LCM? We have got it 30. So now we can multiply here. See 10 3s are 30 and 15 twos are 30. So what I'm going to get here? So I am going to get -3. Remember, there is a negative sign at the denominator. So -3 plus 2. This is the values. Now 1 by u is equals to, this is -3, this is +2. So we have to subtract, and I am going to get -1 here. Bigger number is 3, so I'll get -1 divided by 30. This is the value of 1 by u. Now if I solve for u, I'm going to get -30 centimeter. So this is the answer which we got here. So as I told, it is u. U is nothing but object distance, and -30. I should get negative because always object will be placed on the left hand side. So here I can write the sentence, the negative value of u indicates the object is placed in front of the lens. So let me write the sentence. So this is the sentence which I have written. Now we have to draw the ray diagram. You can see the question, draw ray diagram. So we will draw the ray diagram on the next page. So first we will draw a concave lens. So concave lens will look like this. So see here, I have completed the lens. Now I have to draw the principal axis. So this is the principal axis, and in this lens I'll draw here, right here O, optical center. Somewhere here I'll write F2, and somewhere here I'll write 2F2. This is here F1, and here it is 2F1. So now what I have to do, I have to keep my object that is on the left hand side. So I'm going to keep it at 2F1. So let me draw the object. So here I have drawn my object. I will label it A and B. Now you may be thinking why I have drawn my object and 2F1. So you can see here focal length is given 15 centimeter, and our object distance I have got 30 centimeter. So what is the focal length for concave lens? Always remember, see here, this is the principal focus. So F1 is the principal focus. So rays will get diverged and they will appear to meet at F1. So this is the principal focus. This is focal length. So this is 15, and object distance we have got 30, means double of this. So this is 15. Here it will be 15. So this will become total 30. Therefore our object should be at 2F1 itself, and therefore I have drawn it here. Now some rays will goes parallel to the principal axis and some ray will pass from the optical center. So let me draw the rays. So see here, this is the ray which is going parallel to principal axis. Once it get reflected, it get diverged like this. And if it extended backside, it will pass from this principal focus. The second ray which is going from the optical center, it goes straight. So these will appear on the same side somewhere here. So here I'm going to get my image. So let me draw the image here. So this is here A dash and B dash. This is my image. So see here what I'm telling. So from here to here, the distance is how much? 15. And from here to here, the distance is how much it is? 30 centimeter. And from image to this optical center, this distance is 10 centimeter. All are on the same side, therefore all are negative. So answer also we have got negative. So remember, F was also -15 centimeter and V was also -10 centimeter, and the answer which we have got U, that was also -30 centimeter. All were negative because all we are going to measure on the same side of the concave lens. So this is the ray diagram for this question. I hope you will understand the clear explanation of this question. If you are getting little bit also help, please consider subscribing my channel, share my videos with your friends. Thank you so much.